Friends, we are back, and this time the last incentive of process control is economics. So let's first of all understand what do you mean by the term economics. If we go in for the definition, economics is the study of how societies use scarce resources to produce valuable commodities and distribute them among different people. Behind this definition are the two ideas in economics that the goods are scarce, this is the first point, and that society must use these resources efficiently or optimally or intelligently or wisely, as much you may express it in different terms. Diagrammatically, as you can see, we have limited scarce resources. They go in for the production so that they can fulfill the unlimited wants and needs. This production, you see, we have sufficient for the need but not for the greed. This is what you've been saying. The economic problem is to match the limited resources to the unlimited wants and needs. This is the meaning of economics. Limited resources, unlimited needs. You have to make a balance between these two. This is what you're going to see in case of production, in case of process. So friends, what's happening in a process is that something goes in a process and something comes out of a process. What goes in the process is raw materials primarily, energy in some form, in the form of coal, in the form of oil, in the form of electricity, in the form of biofuel, biomass, and so on and so forth. Services, as we are giving services, engineering services, for example, or other services. Some information goes in the process, and what comes out of the process is, again, it can be some energy may be coming in the high grade energy, or low grade energy may be coming out in some of the processes. Mostly we have the main product, or we call it as just the products, and then we have some byproducts and the waste products. And from the process, as the information is going in, some data is also coming out of the process. So in this process, what we have to do is we have to minimize the input in terms of raw material and energy. We have to maximize the main products, we have to minimize the waste products, and we have to go in for operation at the maximum efficiency point. Any process or any sub process or any equipment, for example, it operates at a certain point when the efficiency is maximum. Efficiency is maximum. It can go beyond that loading also. It can be underloaded, it can be optimally loaded, or it can be overloaded. Optimally loaded means it's loaded at a point where the efficiency is maximum. So, for example, what we see over here is parallel operation of generators. As you can understand from here, if you can see the pointer over here, you have number of gensets, generator sets over here. You have this automatic toggling switch over here. It's connected to the main supply, and this load is connected, and the moment this main supply fails for some reason, it's informed or uninformed failure, this switches on to this side, and depending upon the load, first of all non-essential load is shed immediately and the essential load continues, and this generator set is turned on, and sometimes it remains on. In case of the critical process, always it remaining on, and more generator sets are operating in parallel. As the load increases, the load decreases, then this switching off the generator, switching off of the generator takes place. Means that as the load increases, more and more generators, they start operating in parallel. As the load is decreasing, these gensets are switched off, and all this is to be done automatically. All this is to be done in a manner that the process is a controlled process. We don't want any of these gensets to be either underloaded or overloaded, they be as near to the maximum efficiency point as possible. That way we are going to achieve the economic goal. Economic goal means we don't want to waste the resource in the form of oil in gensets or in the form of steam in gensets, as the case may be. So this is a DG set, diesel generator set, and most of the DG sets, they operate with the maximum efficiency when the load is 65 to 70% of the maximum load. 65 to 70% of the maximum load. That is where you get the maximum amount of efficiency. We have these, let us say, 5 DG sets in parallel, and each is of 1 megawatt. So we keep this thing in mind that we have 5 DG sets. You can operate 1, 2, 3, 4, or all 5 in parallel. Each is of 1 megawatt load, and the efficiency is best obtained at 65 to 70%. We will remember this, and let's see how the things operate thereafter. So at what point, how many generators should be turned on, how many should be turned off, when they should be turned on, when they should be turned off. All this is to be decided in a manner that we develop a kind of algorithm, or we develop a kind of structure, or you can say a rule set, or the rule base, as you may call it, any of the terms we may use, so as to achieve maximum efficiency. So here you can see you have 5 DG sets. They can be more than 5 also in one plant, and this is what I have actually worked on these DG sets. That's why I have a first-hand experience on these DG sets. And what's going to happen here, as you can say, the load is 2.8 megawatt. Right now, let us say the load is 2.8 megawatt in the plant. So how many digits should we use? I can operate 3 digits, I can operate 4 digits, I can operate 5 digits. Of course, I cannot work with 2 digits because the load is more than 2 megawatt. So it looks like even I can go in for 3 megawatt, but it's better I use 4 digits. Why? Because the moment I use 4 digits, 2.8 divided by 4, that comes out to be zero point 0.7. It means the loading is 70%, and if you recall, it's the maximum efficiency takes place at 65 to 70%. So in this particular case, we better operate 4 digit. What if I operate 5 digits? In that case, 2.8 will be divided by 5, and I will get 56% loading, and 56% is lesser than the optimal band of, if you recall, optimal was 65 to 70%. What if I use 3 digits? Again, with 3 digits, 2.8 divided by 3, it will be 93% loading. Again, it is not the optimal value. The optimal value is that with 2.8 megawatt, I must use 4 digits and not 5 digits and not 3 digits. Although काम तो चल जाएगा, the things will be done, but they will not be done efficiently. In one case they will be on the overloaded side, other case it will be underloaded size. Only when we are going to operate 4 DG sets in parallel at this load of 2.8 megawatt, we will have optimal point, or the best efficiency point. This is what we're going for. Now what if the load changes? The load becomes 3.6 megawatt. Then we have to go in for 5 DG sets. The load sheds to 2.2 megawatt. We go in for 3 DG sets. So as the load changes, the parallel operation of DG sets is turned on or turned off in such a manner that we operate at maximum point of efficiency, minimum wastage, minimum consumption of fuel for the given load. So this is one incentive of going in of for a process control where we achieve economics, means limited resources, we use it in the most efficient manner. So friends, we have studied so far the 5 incentives, and ultimately all other incentives, they also boil down to economics. If you recall, the first incentive was safety. That again, if you don't follow the safety rules, damage will take place. Damage to the machinery, damage to the people around, damage to the environment, damage to the product. And again, damage means cost. You're going to lose money. Specification of the products is not met with, we will not be able to sell the products at the required price. Again, as they say, the bottom line is money. Operating constraints, things will overflow, underflow, damage the product. Wastage again, the bottom line is money. Environmental regulations, you will get penalties. The plant may be shut down because of the environmental regulations. Again, it boils down to money. And economics, as we have discussed in this case, the operating at the best efficiency points, the bottom line is money. Bottom line means that after doing all those plus minus, what is the net profit that is written at the bottom of the line of the bottom of the balance sheet, that is called the bottom line. So in journal, in say literally speaking, the final total of an account or a balance sheet is called bottom line. And metaphorically also we say the fundamental and the most important factor is this economics. It's called the bottom line. The bottom line is economics. बहन बढ़ाना भैया सबसे बड़ा रुपया. So this is what we go in for the process control and economics. This is the crux of the whole session we have held this time today. Let's move on to next and conclude. So let's revise that these five incentives are the outcomes. These five incentives which we have discussed till now are the outcome of having a good process control. Because it's an outcome, that's why ultimately it's going to make us richer, wealthier, and having better command in the market as such. These are the incentives, benefits. These are the five incentives, are the outcomes. But to achieve these incentives, the controller which is going to put in the process, is required to do three different types of tasks. So these are the inputs to the process by the process controller, and therefore they become the objectives. The incentives are the outcomes, the objectives are the inputs over here, what is to be achieved by the process control through specifically going in for three different tasks. The outcomes are these five, boiling down to economics. These are how the process controller should behave or should make the process behave in a controlled manner by suppressing the influence of external disturbances. This is one thing. Ensuring the stability of the chemical process. This is the second thing. And optimizing the performance of chemical process. Optimizing the performance of the chemical process of any chemical process. So you can say that these are the three main objectives what the process controller should do in a controlled process, so that we have these five benefits which we have discussed. And these three objectives, as we call it again and again, these will be discussed in the coming sessions and subsequent sessions. So I hope friends now you know what is the role of process control in economics. Specifically, we have discussed the case of DG sets to operate in an optimal manner, in economic manner. So friends, in case you have any queries, let me know. In case you want to share something, some of your experiences, or you want some clarifications, you can contact me over the Zoom sessions or the WhatsApp or the phone call or the face-to-face interaction. As the case may be, I thank you once again with me, and I wish you a safe stay and enjoy learning. Bye-bye.